So let's move on to question 44. This is a slightly tricky question. Well, let's say you have two different models A and B, right? The models look at the effect of two variables in the case of model A and one in the case of model B. SI, which is the number of hours that a student studies, for which a student studies, and A, which is the the talent or the innate ability of each student, right? So number of hours studied and talent or ability. So what effect do number of hours studied and ability have on the marks that a student obtains? This is what these regressions look at. Model A looks at regression, a regression where the number of marks depends on both hours studied and ability, and model B looks at a case where the marks depend only on the number of hours studied. And now the question is, well, the idea behind omitted variable bias is that when you have a case where, well, let's see, alright, let's look at a case where you have two variables which are slightly interconnected, right? One variable depends on the other. The causality might run in either direction, it does not matter. The idea is that if the two variables are connected and they both affect the actual dependent variable that you're looking at, in this particular case, if more talented or less talented students study for different periods of hours, different periods for different numbers of hours on average, then that would affect the regression coefficients that you would get from and make the coefficients from the two regressions different. For example, if S and A were not connected, what would happen is that this beta 2A in this particular regression would go into this epsilon I. Alright, this should be epsilon AI, this should be epsilon BI. So this would both go into this, and this would remain exactly as it is if these two are not connected. The fact that this does change suggests that there is some relation between S and A, and that this is what is driving this omitted variable bias. You're omitting the important variable and important variable ability, which is in fact correlated to an existing variable number of hours studied, and that's creating a bias. Now the question is, how is this connected? The question asks you whether more talented students study for more hours or fewer hours than less talented students. Let's look at a model AI equal to alpha naught plus alpha 1 SI plus UI. So obviously in this case, if alpha 1 is positive, then there's a positive correlation between hours studied and ability, which is to say that more talented students will study for longer hours. Whereas if alpha 1 is negative, then it's the less talented students who will study for longer hours. Now, if we plug this equation back in here for AI, then on simplification we get this particular expression. So once you have this particular expression, then where you have expressed this equation using this particular hypothesized relation between A and S, you express this model A in a manner that is similar to model B. Essentially, you have replaced AI with and picked that up and dumped them into these coefficients here. So all the coefficients, including the error, the coefficient on SI and the intercept, have now changed. Now let's compare this modified version of model A to model B. If you look at the coefficient on SI now, in this particular case, the coefficient is beta 1A plus beta 2A alpha 1, and here obviously it is beta 1B. So beta 1B is equivalent to this, but beta 1B we know is less than beta 1A, which means that this has to be negative, and if this is negative and we know that beta 2A we know is positive, then clearly alpha 1A has to be negative, which means that it is the less talented students who study for longer hours.